Hello, family. Welcome to another session of Maths Fanatics 24/7. In this video, we're going to be looking at the revision of electricity. Right. Before I start answering these questions, I want us to discuss the general symbols that we're going to be working with and their functions on an electric circuit. Okay. So, let's start. So the first symbol that I'm going to start with is the ammeter. This is the symbol for an ammeter. We call it an ammeter. Ammeter. An ammeter basically measures the flow, measures flow of electric current. Okay. This measures the flow of electric current. Okay. Perfect. And then the second symbol is going to be the voltmeter, which is represented by a circle with two lines and a V in between. This is called the voltmeter. It measures the potential difference in the circuit. No? Potential difference in the circuit. Sometimes you can say it measures the voltage. No? The voltage. Okay. And then the units for an ammeter reading or electric current, it's amps. No? Amperes. Okay. And then the symbol for volts, or the units of measurement for voltmeter or potential difference, it's volts. It's volts. Okay. Perfect. And then the third one is the resistance, which is given with a rectangle. When you see this, you know that you are seeing the resistance, né? Which is the resistor. The resistor basically, it prevents or hinders the flow of electric current. So the higher the reading on the resistor, the more hindrance the flow of electricity will experience. So if we increase the voltage, the flow of current will reduce. If we decrease the voltage, the resistance, the flow of current will increase. So resistance is indirectly proportional to the current flow. The higher the resistance, the lower the current, and vice versa. Okay. And the units of measurement for resistance, it's ohms. Ohms with this symbol. Ne? Perfect. Volts, sometimes they just use V, and then for amperes, sometimes they use just A. Okay. Perfect. And then we have a cell. Ne? A cell, which is a basic unit of a battery, right? By definition, a cell is basically a source of electric energy. By converting, it converts chemical energy into electrical energy. Okay, perfect. And then we have a battery. A battery is basically two or more cells joined together. Ne? Okay, this is a positive terminal, this is a negative terminal. So a positive terminal, a negative. So this is a battery, or basically composed of two cells. Ne? It can be two or more. Once you see more than one cell, you know that it's no longer a cell, it's a battery. Ne? The definition of a battery is two or more cells fused or combined together. Okay. Perfect. And then we have a light bulb. A light bulb doesn't have a definition. You just need to know the symbol of a light bulb. Light bulb. We have a switch. There are two types of switches. You have a closed switch. This is closed switch. And we have an open switch. An open switch looks something like this. No? It's opened. Open switch. Okay, perfect. A closed switch basically ensures that the current is flowing throughout the circuit. There is a complete flow of electrical current. But once a switch is open, then we know that the current cannot flow. And then we say the circuit is opened if it's composed of an open switch. If it's closed, we say the circuit is closed because there's a flow of electrical current. Okay. Perfect. Now we can go straight into the questions. Okay. The first question, they want us to draw a circuit diagram. Okay, A, they say a closed circuit with one cell. Okay, so the circuit must be closed. So, okay, let's see. So we have one cell there, right? You show the positive and the negative terminal. Then we know we're gonna go this way and that way. So I put one cell, two light bulbs. So two light bulbs, I'll just put them in series, né? In series. But even if you put them in parallel, it's still correct because they didn't specify, right? In parallel, basically, they will be like this. Switch light bulb 1, light bulb 2, and then they'll be like that. Né? And then there and there. Those are in parallel, right? The current, if it comes here, it's going to split, right? It's going to go there and there. So here the current doesn't split. Because they didn't specify, I'll just put them in series. Okay. And then we have a switch. But they said a closed circuit, which means a switch must be closed. So I'll draw a closed switch here. That is a closed circuit. Perfect. Now let's go to the second one. The second one, they want us to draw an open circuit. Okay, I know that I'm going to have a switch that is basically opened because they say an open circuit, okay, with two cells, okay. This is the first cell, that is the second cell. Then you show a positive and a negative terminal. And then you do this, you do that. Two light bulbs. Okay, I'll still connect them in series. First bulb, second light bulb there, right? A switch in series. The switch is going to be opened now, right? Because they said it's an open circuit, right? It's an open circuit, so the switch must be opened. And then you complete, you join. That is the answer for this question. Perfect. A closed circuit. So a closed circuit, I know that my switch is going to be closed with one cell. So one cell, positive, negative terminal, a resistor in series. So a resistor, remember the symbol of a resistor is a rectangle, right? With an ammeter to measure the current. So there's an ammeter there. And the voltmeter to measure the potential difference, okay? There's a V there. Okay, but the voltmeter is always connected, not across, no? It's always connected across. So a voltmeter is going to be here. You always connect it across the resistor or across the light bulb. Don't forget, a voltmeter, it's always connected across. Right, if you connect the voltmeter here, basically it's incorrect because here you would have connected it with wires. Ne? It's going to read 0. It's going to read 0 basically because wires, a copper wire has 0 resistance. So voltmeter is going to read 0 as well because voltmeter and resistance are directly proportional. The higher the resistance, the higher the reading on the voltmeter. Okay, perfect. Then the circuit is closed. They didn't say anything about a switch, so I'm not going to draw a switch. Okay. And then let's check another one. Yeah, let's see here. They say a closed circuit with two cells. Okay. So two cells, 1, 2, positive, negative terminal. And then you draw your lines. Two cells in series. Okay, there. So what if they said two cells in parallel? If they said in parallel, this is how you're going to do it. No? This is your first cell. That is your second cell. And then you do this. You do that. And then you go out. You go out. No? Those are. Then this will be your positive terminal and your negative. But now they're in series. So they're just following each other like that. Two bulbs in parallel. Okay. So the light bulbs are now in parallel. You are going to have a branch. No? So this is the first. That is the second bulb in parallel. And then you do that. And then they said a closed switch. So, I mean a closed circuit. So we're not going to have an open space anywhere. Okay. And then now let's do E. They say we need to draw a closed circuit with an ammeter. 3 cells. I always start with cells in parallel. Okay, the cells are now in parallel. So this is the first cell. That is the second cell. That is the third cell. You show positive, you show negative, right? So the cells are connected this way. And then you have that. And then those are your 3 cells in parallel, right? Sharp. And then they said an ammeter. So I'm going to put an ammeter here, right? Then they said a resistor. I'll put it there. And then they say what? Okay, let's see what we have so far. We put our ammeter, we put our resistor in series to the circuit with a voltmeter connected to measure the potential difference across the 3 cells. So our voltmeter in this case will be connected here. It can go inside or, okay, let me take it outside actually. Let's see. Let me take it outside. So our voltmeter is going to be there and there, there, and then there. And then you show that that is a voltmeter measuring the total potential difference produced, right? Perfect. And then that's it with drawing circuit diagrams. Now we're going to go to number 2. Let's see what on number 2 wants, right? So question 2, they say, look at the following circuit diagrams and identify the number of bulbs, switches, and cells in this circuit. Identify whether they are in series or parallel. Okay, so now let's answer these questions. So obviously you can see that there are 1, 2, 3 cells in series. They are in series, these ones, right? Because they said we need to connect to say whether they are in series or parallel, right? And then there are switches, 2 switches, right? 2 switches. Switches, you're always going to say series. And then if you check here, there are 2 bulbs in parallel. These 2 are in parallel and 1 in series. So there are 3 bulbs in total and 2 in parallel. In parallel, perfect. And then the third one is in series with the 2 in parallel. But if you say 2 in parallel, it's sufficient because we by default know that therefore the third one is going to be in series. Okay, and then that's it with that question. Now let's check the third one. Ian bought a string of Christmas trees, Christmas tree lights, and hang them in the tree and plug them in. One of the light breaks. What happens to the rest of the light bulbs? If one bulb breaks, the other one will still be lit, right? The other ones, the other lights will still be on, still be on, right? They say explain your answer to question A. Okay, I'm just going to explain. I'm not going to write. So remember, Christmas tree lights, they are connected in parallel, which means there is a split in the flow of current, right, into each light. So when one breaks, the circuit will still be complete, which means if they're connected in parallel, when one goes off, it does not disturb the flow of what? Of current. So there will still be a flow in the other bulb since they are connected in parallel. And that is the reason for B. Okay, perfect. Household circuits are in parallel. Explain why it's better to use a parallel circuit in a house than in series. Okay, a parallel circuit basically ensures that each component is connected independently, right? If there is something off with one of the components, let's say a light bulb, a fridge, a stove, a geyser, or something else, right? It is not going to affect the functioning of the other components. That is why we connected all our things in parallel. Perfect. And the other reason you can say is parallel circuits basically means we have less resistance, which means less energy is required to push the flow of current, thus saving cost of electricity. If they were in series, we were going to have an issue where basically our current, the energy required to push the current will be high, which will mean that we are going to be spending more. That makes sense. Perfect. Okay, let's go to 5. So on question 5, they say answer the following questions on the circuit below. Okay, so before we answer the questions, I need to explain how electricity flows. Electricity basically flows from the highest terminal, which is the positive, to the negative terminal. To the negative. So it's going to flow this way, right? It flows, it flows, it flows. When I say electricity, I mean the current. So the current that was discharged here doesn't change as we flow. It passes through there, no split, it keeps on going, there's no split. So if I were to have A3 here, which is ammeter number 3, the reading for A3 and A2 will be the same because there was no split, which passes through there. And on A1 still, there won't be a difference in the reading on the ammeters. So the total reading on each ammeter would be the same because everything is in series here. So they say A1 was 3A, therefore A2 will be 3A, right? Work out the missing values. So we worked out the missing value. Then they say explain your answer. We have explained that the current flow is the same throughout the circuit since all the components are connected in series. And then that is the reason for this one. Okay. Let's now go to question number 6. Question number 6. They say answer the following questions on the circuit below. Okay, sharp. So let's answer that question. Let's answer the question. The first most important thing is always to check how your current flows. So in this case, our current is flowing from here. It goes there. It goes here. When we get to this point here, we're going to have splits. It splits there. It goes there. It goes there. It splits here. It goes here, it goes here, it goes here, it splits, and then it all go up until there, up until there, up until there. It passes through, then it comes here, it joins again here, it goes there, it joins here, it goes there. So A basically gives us the total current. Can you see it? A1 is the total current on the circuit. Perfect. So whatever enters here will be the same as there, which is the same as this, right? And whatever enters here would be the same as there because here it splits and then here it recombines. Perfect. Now, let's see the clues that they give us here. They say, okay, they give us the reading on A4. A4 is 1 amp, so here it's 1 amperes. And then on A3, we have 3 amperes. The reading is 3 amperes there. And then on A2 is also 3 amperes, right? So, and by looking at the reading on the ammeters, now we can easily tell that this light bulb and this one have the same resistances. Why? Because the ammeter readings are the same, right? But this one is going to have a higher resistance as compared to this ones. Why? Because the flow of current here is less than there. So this bulb has a higher resistance than this because the flow of current is less there, right? Then we can see that, okay, to get the total is here. It's this plus that, right? So the total, which is A1, is going to be 7 amps, right? And then we have explained that the current, okay, they need the explanation for the answer. Your explanation is going to be that the current splits into A2, A3, and A4. Ne? And then when you add the sum of each individual ammeter, you're going to get the total current of the circuit, which is your A1, basically. Okay, perfect. Now let's go to question 7. Now let's talk about a voltmeter. The voltmeter basically is the potential difference. Ne? The potential difference. So V1 is the total output because it's on the battery. So V1 gives us the total, ne? Which means V3 plus V2 must add up to this total here. The total is the sum of V3 and V2 because it's outputted here. It goes this way. It's measured there. It's also measured there, right? So now let's see. We go into, okay. So we can easily see that V3 must be 4 volts, so that V2 and V3 are going to add up to the total. Né? Then the explanation of your answer will be that V1 is the sum of V2 and V3 since it's on the power source, so it's the total resistance on the circuit. So when you add this and that, you get the total there. Then we answered that question. Now we can go to question 8. So question 8. Now here, guys. Okay, before I basically go here, let's go back up. Ne? If you check here, our light bulbs are connected in series. Ne? If they're connected in series, the reading on V1 and V3 are not necessarily going to be the same. They can be the same, they cannot be the same, right? For example, if the reading here was 6 volts, here it's going to be 6 volts as well, so that the total is still 12 on the totaling to the sum of the battery, right? Which is 12 volts basically. Perfect. Now let's go discuss components connected in parallel, right? You see here the light bulbs are connected in parallel because the current will split at this point here. You see, remember it comes this way, and then here it split, it goes there, it also goes there. Ne? So once, this is very important, you need to know this, and it's very, very important. When components are connected in parallel, they are going to have the same voltage. The voltmeter reading V2 and V3 will be exactly the same. Exactly the same. Ne? Perfect. Basically, what I mean here is, if they're connected in parallel, we can replace them with a V4 here, ne? Which is going to measure here and here, right? Perfect. Now, the total in this case is V1 because it's on the battery is 10, right? And then remember, these 2 voltmeters can be replaced with 1 voltmeter. And then this voltmeter will be 10 volts because it's the only voltmeter on the circuit, right? And let's see basically here. Let's see. Yes, so this will be 10 volts and that will be 10 volts. Right. Perfect. So you think of it as one thing, basically. Don't think of it as 2 different things. Okay. Perfect. They say explain your answer above. You're going to say the light bulbs are connected in parallel, which means they share the same voltage. Ne? The voltage is exactly the same, which is going to be the same as the voltmeter reading 1 of the power source. Okay, perfect. Now they say, how many bulbs will still glow if S1 is open? Let's check S1. S1 is here, right? So if S1 is opened, we can see that, okay, the power moves from here to there. So which means if this is open, the power will not be able to pass here, which means all the bulbs are going to go out. So none of the bulbs is going to glow if S1 is open, right? But now let's see if S2 is opened. If S2 is opened, let's see. Let me see. So this guy here is open, right? Which means the current cannot flow on this path here because there's an open space there. So that only two bulbs is going to flow because the current will now be flowing this way. Will be flowing this way now. Perfect. And then let's check what else comes after that. Okay, let's go to 9. So on 9, they say, okay, they say each cell in this circuit is 1.5 volts. Ne? And then we can see that the cells are connected in parallel. Remember, I said a parallel connection shares the same voltage. So if each cell is 1.5 volts, the total will be 1.5 volts because they are connected in parallel. But let's say they were connected in series and each was 1.5. The total was going to be 4.5 now because each cell will be contributing with 1.5 volts. Ne? So if they're in parallel, you just take the voltmeter reading on the first one, and then it's going to be the same throughout. So it's 1.5 volts. Perfect. And we're done with that question. We can now check question 10. So on question 10, they say answer the following questions about the circuit below. Okay, sharp. Remember, before you answer the question, you always have to analyze first, right? How the current flows. So the current moves from this, it goes there, it goes there, it goes there. I advise you to now pause the video and try to answer the question and resume to see if you have an understanding so far. Perfect. And then when we get here, the current split, it's going to come here and there because the splits there. So it comes here, flows, it flows, it flows, flows, it flows, it flows. Then it recombines here. So whatever enters here will be the same here because this comes there, this comes there, it recombines. So A1 gives us the total current of the power. So this is the total current because here is going to the battery, there is the same, you see. Perfect. So now let's check. If I know the reading on A2, I can easily get the reading on A3 because the total current is 6 amps on A1. So if this is 2, this must be 4 amps then. Okay. Perfect. And then I can see that, okay, the light bulbs are connected in what? In parallel. So the reading on V2 and V3 will be the same as the reading on the battery. Remember, I said if they're in parallel, you treat it as a 1 voltmeter basically. And they told us that that is 9 volts. So you can easily see that, okay, if it's 9 volts, this is also going to be 9 volts and 9 volts. No? You treat it as 1. Don't add them to say 18. It's just 1 voltmeter basically. And it's going to be the same as the total there. Right. So this will be 9 volts and 9 volts, right? Perfect. And then let's see what else I need to discuss. Okay, they can ask you why does this current does not flow into the voltmeter? The reason why current does not flow into the voltmeter is because a voltmeter is made up of extremely high resistance. And resistance being high means that the current cannot flow at all there. So the current can never flow into the wires of a voltmeter because a voltmeter is made up of infinitesimally large resistance. So it's going to prevent any flow of current, right? Because if the current flew into the voltmeter, it was going to damage it. So they made sure that the wires of a voltmeter are made up of extremely high resistance. So no current flows there. That makes sense. And the other question they can ask you here is, what is the reading of each cell? So the cells are connected in parallel, in series. And you can see that there are 3 cells and the total is 9, which means each cell is going to be 3 volts. So that if we say 3 times 3 is going to give us the total of 9 volts. Ne? Remember, I said if they're in series, you add individual cells. Perfect. And that's the answer for that question. Now they say, what will the reading on A2, what will the reading on A2 show if switch S2 is open? Let's check. S2 is here. So any path that is on S2 is going to be cancelled. So this part here will go away now. So the current will just be here, right? So the reading on A2 is going to be basically the same as here because there's no longer going to be a split here. So it's going to be 6 amps. Right. Sharp. And then, so here you're going to say 6 amperes. And then here I just explained, I said, because if the switch 2 is opened, now we're going to have a completely circuit that is connected in series, which means there's no split in current. Therefore, the current flow throughout the circuit will be the same as the total current of 6 amps. Okay, that's that. Which bulb, A or B, has a higher resistance? Let's check. Bulb A or B. Obviously, on A2, we can see that the current is what? Okay, let me just adjust here. On A2, they said the flow of current is 2A, right? And then on A3, we said it's going to be 4A. So the higher the current, the less resistance, ne? Less resistance. So this one has high resistance because the current is less. The flow of current is less. It means there's high resistance. You get it? Perfect. And then now let's go check. I'm sure I answered that question. So which bulb is going to be having a higher resistance? We're going to say A2 is having a higher resistance because of less flow of current. The lesser the flow of current, the higher the resistance. Do we get it? Perfect. Now let's see. Explain your answer in the previous question. I just explained. I said because there's a less flow of current, the resistance is going to be higher. Perfect. Then now let's see. They say calculate the resistance of bulb A and B. Okay, let's check. So we need the resistance of bulb A and B. Okay. So to solve for the resistance, we have this formula. Ne? We have the formula that is V, which is the voltmeter, is the same as I times R. Ne? Sharp. And then the voltmeter, okay, let's do voltmeter 2, which will give us I2 and resistor A, which is the light bulb, right? Now let's do this. Voltmeter 2, we said it was 9 volts. So voltmeter 2 is 9 volts. So I'm going to put 9 here. And then the resistance, the current flow on 2 is 2A. So it's going to be 2 times resistance A. Right. Okay. And then now let's see what we do. So let's see now here we can see that, okay, to get the R on A by itself, we're going to divide by 2 both sides. Then this gives us 4.5. It gives us 4.5 ohms, which is the resistance on light bulb A, right? Perfect. Now we're going to do V3 equals to I3 plus resistor B. You see, the reason why I'm using V3 is because it's on resistor B, and A3 is basically our current, which is represented by the I. Ne? So the formula basically is V equals to IR. This is the very most important formula you use. Ne? If they can give you the current and the resistance, they ask you to solve for the voltage, and they can give you basically one of the they will always give you 2 of the 3 unknowns. Then they'll ask you to solve for the third one, right? Perfect. So now let's proceed. The V13 is still 9 volts, right? Ion 3, we found it as 4 times RB, right? Now we divide by 4 both sides. What is 9 divided by 4? Let's check 9 divided by 4 quickly. So 9 divided by 4 gives us 2.25, right? This gives us 2.25 ohms equals to R on B, right? Which is true because here basically we said the resistance is less. You see, you can see that the resistance here is less than on A. Why? Because the current flow here is higher. So there's going to be less resistance as we had reasoned before. Do you see it? Perfect. And then I can show you a formula to calculate the total resistance in series and in parallel. Let me do that actually, in case they ask you in the exam. Okay. So I'm going to draw 2 scenarios here. So the first one is in series. So in series, we're basically going to have, let's say the resistor 1, let's say this was 3 ohms. Then we have a resistor 2 connected in series to that one, right? Let's say this was 5 ohms. Ne? The total resistance in series is going to be R total is basically 3. You just add the individual resistors, which gives us 8 ohms, right? That was in series. In series, it's easy. You just add everything. But now let's see in parallel. In parallel, let's say the resistors were in parallel just like that. Parallel. So in parallel, you are going to have 1, you do a fraction. 1 over R total is equals to the ratio of 1 over the first resistor, which is 4.5, plus the second resistor, which is 2.25, right? If you had the third one, you are going to say plus 1 over whatever the resistance is, and so on, right? Now let's add 1 over 4.5 plus 1 over 2.25. Now we're going to have 1 over RT, which is 2 over 3. Therefore, you flip this, you're going to have RT equals to, you flip that, which is 3 over 2 ohms, which is basically 1.5 ohms. Do you see that the reason why in the household we connect in parallel is because of this same reason here? If these two were in series, let's see how much we're going to just add them. So it was going to be 4.5 plus 2.25. It was going to be 6.75. So in series, the resistance in the circuit becomes higher, which means more energy is required to push the electric current, right? But in parallel, it's good because the total resistance is always smaller than when we have a series connection. Perfect. And now we can move on to the next question. Explain, okay? So we did that. Then we did this. We finished that. And that's it with this revision, right? Tune through for the next session where we'll be talking about safety of electricity. Okay. Thank you very much. Aluta continua. Tango.